Hello everyone, hope you all are doing well. So now we will start our new topic, that is absolute gravitational potential energy. So firstly we should know that what is absolute gravitational potential energy. Work done on a body work done on a body to take a inside gravitational field to outside means a infinity point outside it infinity point of gravitational field. So this is a definition of absolute gravitational potential energy. The work done on a body to take an inside gravitational field to outside means it infinity point of gravitational field. So let me make a one diagram for you for understanding. So let's see, this is a one diagram. Okay, this is our earth. Okay, and this earth we are having one mass. Okay, it's a inside one body of the gravitational field, but what we will do, this is the outer surface of the gravitational field, means infinity point where gravitational field will be zero and potential energy will be zero. So this point we will try to move outside from this circle, from surrounding, so it will be here. So here gravitational field will be zero, potential energy will be zero. So the definition is work done on a body, this is a body, we have done a work on it to take this one from inside to outside at the infinity point of gravitational field. So let's move further. There are some rules that should be happen in absolute gravitational potential energy. Number one is body must be in equilibrium, means our body must be in equilibrium. Okay, our second point is that work here work done on a variable force. As you remember, if you are watching from the last videos, so there we have done with work done on a variable force and work done on a constant force. So we will talk further about the work done on a variable force. We will prove that how work is done on a variable force. So this was a simple definition of absolute gravitational potential energy and some points. Now let's move further to prove work done on a variable force, how we will calculate that. Okay, so let's move further over here. That I said that I will explain that work done on a variable force how. So just wait. Okay, so let's move over here. As you can see that here is one diagram in which I have made a earth. Here is the radius of earth, here is the mass of earth, and this earth, and this is a mass of one mass we are having. Now this one line is called the radius of the earth. This is the radius distance from distance from the mass to the infinity, means distance from the radius of earth to the infinity. This is the radius of earth from here to the infinity point, what the distance they covered between, so that we will know with this one line, and the radius of earth we will define with this one line. So just wait. Now you can check it out over here, that here is first mass, means here this is our infinity point. We are not taking exact, this is our infinity point. But one more thing, where we will calculate it on the equal distance, means if we are taking one distance of 2 joules, so all the distances will be 2 joules between them. Now this is our r1 radius 1, this is r2 radius of r2, then 3, and then 4. Okay, so let's move further, that this is our r1, this is our mass from at the top of the ground of the earth, and we put on the infinity point. So this is our r1. Okay, this r1 and this is our r2. Now what we have to do, we have to find this one value between them. Okay, so to find this one value, we will use a formula, that is delta r is equal to r2 minus r1. when you will use this one formula, so you can easily find, like if we are having this one line 2 meter, okay, and this one line 1 meter, okay, so 2 minus 1 meter will remain, so it means the space between this one line is 1 meter, okay. Del radius between this line is what meter? 1 meter. But now one more thing over here, let me show you one more thing over here, that if we are having here I have written that delta r is equal to r2 minus r1 and delta r is equal to 0. Why r is equal to 0? So r is equal to 0 in the position where we will find the distance. This was the distance that we find between these two, okay. But now what we have to do, we have to know this both covered, means previously we don't know the distance of this one from one point to another, but now we know the distance of one point to another, so we'll find the total distance between them. So we will use formula again, delta r is equal to r2 minus r1, okay, r2 minus r1. So what will happen over here, now we also know this one, that it's a 1 and 1 we are having previous one of 1 meter, so 1 plus 1 we are having 2 meter, it means first line is also 2 meter, second line is also 2 meter, because we find the between distance of this. Now we will do 2 minus 2, so we are having radius over there 0, because we are finding equal distance between them. After that, one more thing, that after that we are having this is on the earth, this mass is on the earth, okay. Let me make another, like this is a mass, this is on a earth, okay, on the earth surface. Now what we will do here, it's a gravitational force is gravitational field, due to gravitational field, and here we put the force, and we also gaining the distance like from one point to another. So force into distance, as we discussed in yesterday's lecture, is equal to work. So with work, this mass is changing its position from one point to another, and with also having gravitational field downward, so this is the perpendicular to each other, and it will make 180 degree, that is equal to minus 1, okay, means negative. So 180 degree it's making, because it's the perpendicular to each other. Now what we will do here, we have given the name of these, like here work is happening from 1 to 2, then 2 to 3, then 3 to 4, but at infinity position what will happen, we will be having work n minus 1 to n. Now what is n? N is the infinity point. Now you will say that why you put n minus 1 over here. Let's suppose we are having infinity point 7, okay, we don't know infinity point, but we supposing that 7 is our infinity point, so we will put we know now the n is equal to 7, so we will put here 7 minus 1, here will be 6. It means from work happens from 6 to 7. Actually that's why we put over here n minus 1 over n. Now let's move further. Now we will just prove it, that how we can find the total work, means total work between from one point, from our main ground point to infinity point. So let's suppose here we are having, just wait, I should move it more further. Okay, so here we are having formula of the variable force that we discussed previous in upper one portion, that work is equal to variable force. To find the variable force, we are having formula work from 1 power n, means from ground point to the infinity point, work from 1 to 2 plus 1 2 to 3 plus 3 to 4 and plus n minus 1 to infinity. This is our equation 1. After that we know the formula of work, so we put the formula of work, that is work is equal to f dot d cos theta, okay, done also. After that here with force we are putting the gravity, we are also having gravitational field, so we put g over here. After that in the place of d we are having r, means we were finding radius in the place of distance, so we put del r over here. After that to move downward, we know that del r is equal to r2 minus r1. We change the value with del r to r2 minus r1, and here we are having cos theta. So cos theta is equal to 180, so we put 180 over here, okay. Now let's move further. After that, what we did, that here at the place of Fg we put the formula this one, like we are having formula F is equal to G m1 m2 upon r square. So we are having a formula of force that we are having is equal to me, mass of earth, with one mass that we are having, and radius means distance between them. So what we did, we just put that one formula over here, G me upon m r square, and all the things remain same. Means this one, after that r to r minus same, as I told you cos 180 is equal to -1, so we put -1 over here. Now what we did, that we have put here we are finding over here work from 1 to 2, means from for just this one work. When we will find this one work, so this one work and this one work and this one work all will same. So work from 1 to 2, what happens here, -1 multiply with this, so minus sign come over here and all the remain same. After that, as I told you, that delta r is equal to r2 minus r1, and r, if delta r is equal to r2 minus r1, so r1 radius 1 is equal to r, radius 2 is also is equal to r. So we can write here like if r1 is also equal to r, okay, and r2 is also equal to r, so r multiplied by r, we are having r square, so we put over here r square is equal to r1 into r2, okay. So let's move further, that here we are having remain same sign of minus, okay. Now at the place of r square we put here r1 r2 and all the remain same. After that, what we did, we divided with this one, so here r2 minus r1 upon r1 upon r1 multiplied by r2, okay, and this one remains same, that is minus g me and m. After that, what we did, that r2 upon r1 r2 on one side and minus r1 upon r1 r2 as second side. So we cut r1 with r1 and r2 with r2, so our just remaining that 1 upon r1 minus 1 upon r2. So we have find over here work from 1 to 2. How we will find work from one motion to second motion, okay. Now we put this value in equation 1 that we have done over here, so all the equation will remain same. So what will happen here, that here put this value in equation 1, so work 1 from n, means from ground point to infinity point, is equal to 1 upon 1 to 1 to 2, 2 to 3, 3 to 4, and then infinite position. So what we did over here, just wait, okay, what we did over here, that we put over here work from 1 to 2, that we are in r1 r2, then 2 to 3, so we put also r2 r3, then 3 to 4 we put r3 r4, all will remain same, just their radius will be changed, so infinite position between them. So one time at last point it will be rn minus 1 and rn. After that, what we did, that we have taken a common of minus g m, so we taking the common of that gravity, mass of earth and mass, so we put over here 1 upon r1, this one I am also cutting this one, like that one we will done, so we will also cut that one, okay. So like we have taken common over here, I have put 1 upon r1, same here, then I put minus 1 upon r2, same here. After that, we are having this one plus 1 upon r2, how plus, like it's plus minus will again remain this one value minus, okay. So move next, 1 upon r2, after that we put minus 1 upon 3, okay, then again plus over here, then 1 upon r3 done, then minus 1 upon r4 done. So after it one infinite position, we will be having 1 upon r, 1 upon 4, 1 upon r4, and after that we are having minus 1 upon n minus 1, and then plus 1 upon r n minus 1 and minus 1 upon r n minus 1, then this 2 over here. Before that we will be having this one, like from 1 to 2, so 2 will again come in the first, so it is 4, so 4 will again come in the first, then r n minus 1, then next this one we will put over here, okay. So we cut this plus minus plus minus plus minus plus minus, so in last what will what remain to us, just this one position remain to us, that is work 1 from means ground position to infinite position, we are having minus gravity, mass of earth and mass and common we are having, we can find it with 1 upon r1 minus 1 upon rn. If we know the infinity position, we will put infinity position here and our radius 1 here. Okay, so we will find the all total variable force, means work done by a variable force. So we just take it out at how we can find from ground position. Like previously we were finding on the equal position from 1 to 2, 2 to 3, but if we want to find total together, so how we can find total? So with this one formula. Hope you understand today's lecture. Thank you so much for listening.